Hello everyone, welcome to this new session. So in our previous session of control system, we have discussed one problem related to this control system, right? We have solved one mechanical system, so we are going to continue that. So this is the second problem here, you can see here. This is the given physical system here. For this we need to write the equivalent analogous system, and we need to represent the analogous circuits in FV Anology and FI Anology. Okay, yeah. So the first step here, what we need to do is we need to write the equivalent mechanical network, right? So first we have the components here in this system. One is spring, mass and force, and this is the displacement happening. So because of this displacement, this mass is getting displaced, along with that this spring is getting displaced. Force is responsible for this. So first thing is that first make a node and name it as x of t, that is the displacement, and after that draw the force f of t, and in the same node mass, because due to that force mass is getting displaced, along with that the spring is getting displaced as well, and along with that this arrow sign represents the friction. Okay, because the friction is taking place here, so this is indicated by an arrow here. Okay, so but in order to represent a friction we write it like this. Okay, yeah. So then join this, and if you want you can make this as a surface here, name it K, B and M. Okay, and after that firstly you need to know the equilibrium equation. Okay, so the basic equilibrium equation for mechanical network goes like this. You have written it already, so I am going to write it again. M into d square x of t by dt square plus b into dx of t by dt plus k into x of t. Okay, yeah. So the first thing now we need to apply FV Anology for this circuit. Okay, so in FV Anology we know that force is replaced by, wait, I'll get you the table. So we know that in FV and FI analogy, these are the few of the replacements that is here. Force is replaced by voltage in case of FV analogy. Okay, so yeah, first thing f of t would be replaced by v of t here right now, is equal to this m is replaced by l in FV, right? So it would be l into d square, and x is replaced by q. Okay, so it would be q divided by dt square, plus again we have b here, but b is replaced by r, so r into d, x of t is replaced by again q, so r dq by dt, plus k is replaced by 1 by c, so 1 by c into x of t is equal to q. Okay, so now again simplify this, so this would be l into, take d by dt outside, into dq by dt plus again r dq by dt plus 1 by c into q. Okay, here we need to know the relation of I is equal to dq by dt. Also we can say that q is equal to integration of I. Since if we take this differentiation to other side, it would be q is equal to integration of I. So we need to substitute these two in this equation now. In this equation, that is v of t is equal to L into d by dt of dq by dt is equal to I, so write it as I, plus r into I again, plus 1 by c into integration of I. Okay, I into dt. So now v of t is equal to L into di by dt plus ri plus 1 by c integration of I. Okay, so now the next step here is we need to apply the Laplace transform here, as I said in the previous sum as well. We need to consider the equation of the, after applying the Laplace transform, that equation we need to consider, and we need to build the circuits. Okay, so yeah, Taking Laplace transform also, I have told you one relation, right? Whenever there is a differentiation, we need to multiply into s, and whenever there is an integration, we need to replace it. We need to replace it by 1 by s. Okay, these two things I have told you in the previous sum as well. So again, we are going to apply that here also. So v of t would be replaced by v of s. Time domain is replaced by s domain, is equal to L into d by dt is replaced by s, and I is equal to I is replaced by I of s, plus R into again I of s, plus 1 by c, and integration is replaced by 1 by s, so I'll write directly as 1 by cs into I of s. So this is your equation of FV Anology. So now using this equation, let's try to build a circuit here. Since we have only a single displacement, that is x of t, so we don't have any other equations for FV Anology. So let's try to build the circuit. We know that FV Anology, we need to use the loop current technique, that is we need to consider loops, and inside the components R, L, C would be in series. Okay, so here we can see that L, C as well as R, all of them are present. So it's very simple, that is R, L and C we need to connect in series. Along with that, we would be having a voltage source, that is V of t. Okay, and that we need to close it in a single loop of I of t and name it as R, L, C. So this is your FV Anology electrical equivalent electrical circuit. Okay, electric network. So this, like this, we have built it for FV Anology. So now let's see for FI Anology as well. So now in FI Anology, we know that the force F of t is replaced by I of t, that is current, and M is replaced by 1 by R. Sorry, M is replaced by C d square, and x of t is replaced by phi in case of FI Anology by dt square, plus B is replaced by 1 by R into d phi by dt, because the x of t is replaced by phi again, plus, and k is replaced by 1 by L into phi. Okay, so now again simplify this further. C into d by dt of d phi by dt plus 1 by R d phi by dt plus 1 by L into phi. Also we have a relation that V is equal to d phi by dt, right? In case of FI Anology, also we can write phi is equal to integration of V. Okay, so these two things we are going to substitute in this above equation right now, as we say similarly as we did for FV, same way. I of t is equal to C into d by dt of d phi by dt is equal to V plus 1 by R into V again, plus 1 by L into phi is equal to integration of V. Okay, yeah. So now we need to apply Laplace transform. So write again, taking Laplace transform. So this I of t would be replaced by I of s again, t domain would be replaced by s domain, C and d by dt is replaced by s, V is replaced by V of s, plus one by R into V of s again, plus 1 by L, and integration is replaced by s, 1 by s, so 1 by ls into V of s. So this is your FI Anology equation. So now using this, we need to build an electrical network, equivalent electrical network for FI Anology. Okay, so as I have told that in FV Anology, we will be using the concepts of loop currents, and we will be writing the loops and writing the circuit. In case of FI Anology, it's the reverse of that, that is we need to apply node analysis, that is we need to consider nodes. Okay, since we have only a single voltage, that is V of t, so consider that node and write it as V of t, and along with that we have all the components such as L, C, R in parallel. So first thing what we need to do is built a current source that is name it as I of t, and first one is capacitance, then it is resistance, inductance, LCR in parallel. Okay, CR. So you can build it in any such manner. It doesn't mean that only capacitor should come first. Any of the three can come first. Okay, yeah. So this is the equivalent network. So this was basically a simple problem. So the problem which I have done first, it was a bit tough. Actually, I wanted to do this problem first, but I was not having this question, so that's why I have done it right now. So this is one basic problem. So in this video, one more problem we are going to solve related to this. Okay. So yeah, we'll move into the next question. So this is your next physical system. So this is basically the next question for you all. So here you can see that in a air medium, open surface air medium, we can see that there are two frictions connected here, B1 and B2, and along with that there is a spring K and two masses M1 and M2. Since there are two masses, we can see that there are two displacements as well, that is x1 of t and x2 of t. So due to these two masses, the two displacements are occurring, and we can see that this component B2 is between M1 and M2. So we need to be very careful while writing the equivalent mechanical system right now first here. So the first step is we need to draw the mechanical system, right? Yeah. So here the total displacements are x1 of t, x2 of t. So two nodes we need to draw it first. x1 of t, x2 of t, and after that, the first observation we can see here that this friction B2 is between these two displacements. So the first thing we need to draw is we need to draw this B2 between these two nodes. Okay, and after that, x1 of t is causing this force F of t. So we will draw this F of t along with the node x1 of t, and after that we have this mass occurring here, M1, due to the displacement x1 of t. So draw M1 here. After that, from the same node, even this B1 is attached, right, to M1. So attach this B1 as well. So this is M1, B1, F of t, and after that in place of x2 of t we have two components, that is M2 and K. Okay, so one is M2 and another one is the spring K. Okay, so this is your equivalent mechanical network. Okay, so observe the circuit very carefully. Okay, how I have written these things. Okay, pause the video, you can refer it down. Again, you can start the video from the starting if you are not understanding anything. You can refer our previous videos as well. Okay, we'll further move on right now. So the first thing we need to write is the equilibrium equation. I have written in short form. Okay, since we have solved two problems, so you might be knowing this. Who are regular to my video, they might be knowing this. So the equilibrium equation, we know that general equilibrium equation is F of t is equal to m into d square x of t, or I'll directly write it as x only, by dt plus b into dx by dt plus kx. Okay, so now let's apply the equilibrium equations at node 1 and node 2, since we have two nodes, right? So we'll write the equilibrium equation at node 1 first, that is x1 of t. So we have one force along with that node, so F of t is equal to m is replaced by m1. Okay, since we have two masses m1 and m2, so m1, and along with that d square x of x1 of t, since the displacement is x1 of t, by dt square, plus b1, in the same node we have again b1, so b1 d x1 of t by dt, since the displacement here is again x1 of t, plus we have one more component, right, that is B2. It is attached to the same node, right? But it is between these two nodes. So what we need to do, I've told you, we need to take the difference between the two nodes, that is B2, and we need to write d by dx, right? In place of b we have d by dt, so d into x1 of t, first node, that is the current present node, write it, by dt, minus the next node, that is d x2 of t by dt. So this is your first equation of node 1, first equilibrium equation. If you want, you can name it as equation 1 as well. So now at node 2, so at node 2 x2 of t, we can see that there is no force attached to it, so directly the force would be equal to 0. And now m2 is attached to m2 d square, and displacement is x2 of t by dt square, plus we have a spring, that is k into x2 of t, plus we have again one more component b2 attached to this only node, right? So again we need to write it b2 into, now this time first we need to consider the displacement x2 of t, okay? We need to do x2 minus x1, not x1 minus x2. So when we are considering x1 node, we need to write x1 minus x2, but when we are considering x2 node, we need to write x2 minus x1, okay? So that step we need to be very careful. So this is one more equation, name it as equation 2. So we got these two equations for node 1 and node 2. So now let's apply the FV analogy. There are two equations, right? So first let's apply for equation 1, right? For equation 1. So for equation 1, this equation, we know that f of t is replaced by v of t, f is replaced by v, right? Yeah, is equal to m1 is replaced by l1. So since m is replaced by l1 into d square, x1 of t is replaced by q1, right? Plus b1 is replaced by r1 dq1 by dt, plus b2 is replaced by r2 dq1 by dt minus dq2 by dt, right? Yeah, so further simplify this, L1 into d by dt of dq1 by dt plus r1 dq1 by dt plus r2 dq1 by dt minus dq2 by dt. Since we know that I is equal to dq by dt, okay, so replace this term dq by dt by I, that is L1 into d. Since we have q1, so we need to consider current I1 by dt plus r1 into I1 once again plus r2 into I1 minus I2, okay? So this is the equation. So for this equation we need to apply the Laplace transform. So if we take Laplace transform, the v of t term is replaced by v of s, and L1 into d by dt is replaced by s, and I1 is replaced by I1 of s plus r1 into I1 of s again plus r2 into I1 of s minus I2 of s. So this is your one equation, for equation 1 we have derived this Laplace transform equation, okay? So name this as equation 3. So now we have one more equation, right, for equation 2, okay? So now consider that equation 2 which we have solved and kept it and named it as equation 2. So in that equation we know that force is 0, so if we replace f by v, again it is 0 itself, and again m2 is replaced by L2, so L2 into d square q2 by dt square, again x2 of t is replaced by q2 plus 1 by c q2, k is replaced by 1 by c, right, plus r2 into dq2 by dt minus dq2 q1 by dt. So again further simplify this, 0 equal to L2 into split this, that is d by dt of dq2 by dt plus 1 by c into q2 plus r2 into dq2 by dt minus dq1 by dt. Again we know that I is equal to dq by dt, right? And also here we have only q term, so we also know that q is equal to integration of I. Okay, so these two things we need to replace it in this equation now. Okay, so that is L2 into dq2 by dt is equal to I, so q2 would be replaced by I2, L2 di2 by dt plus 1 by c into integration of I2, correct, right? R2, q is replaced by integration of I, right? So q2 would be replaced by I2, so this would be I2 minus I1. So now for this equation take the Laplace transform. Taking Laplace transform we get, so this is 0 itself. L2 into d by dt would be replaced by s and I2 would be replaced by I2 of s plus 1 by c, and integration is replaced by 1 by s, so 1 by cs into I2 of s plus R2 into I2 of s minus I1 of s. So this is your one more equation while we solve for equation 2. So name it as equation 4. So in these, using these two equations, that is equation 3 and equation 4, we will be building the circuit for FV analogy, equivalent electric circuit. Okay. So the first observation you need to do here is, since we have two currents, two nodes, so automatically we can say that we also have two currents. Okay, so if we have two currents also, we know that we need to use the method for loop current, so we would be having two loops, that is one is I1 of t and another one is I2 of t. First write those two loops here in order to avoid confusion. Okay, I2 of t, and after that we know that in the first loop, that is in the first equation we have this v of s term, so near the first loop first write this v of t voltage source. Okay, and also we can see that along with this I1 of s, I1 of s means this is in the s domain, right? So if we replace, if we consider t domain, if we see I1 components, along with that which and all other terms are there. I1 of s we have here L1, R1, also R2, but this R2 is between I1 and I2, right? Yeah, so between I1 and I2 means it should be coming under both the loops, right? So first thing we observe that R2 is coming under these two, between these two loops, so right, like this R2 first, and after that L1 and R1 is coming under loop 1, so L1, R1, and this is R2. Okay, so this completes the first loop. So now let's consider the second loop, that is the second current I2 of s. So here we can see that we have under I2 of s we have two components, that is L2 as well as C. Since this R2 is already written between these two loops, only these two components are left, L2 and C, and those two are in series again. So L2 and C. This is in series, right? This is C, this is L2. So this completes the equivalent electrical network for FV analogy. Okay. Again, please pause the video and refer it, and if you do not understand, look at the video once again. So this is very, very important here. So we are continuing this right now. So now let's try to build the circuit for FI analogy. Okay, so now let's build the circuit for FI analogy similarly. So for FI analogy, let's first consider the equation 1. For equation 1, we need to write that is force is replaced by current, right? So write I of t is equal to M is replaced by C, so M1 is replaced by C1 into d square. That is displacement x is replaced by phi 1 d square phi 1 by dt square plus b is replaced by r, so b1 is replaced by 1 by r1. B is replaced by 1 by r in case of FI analogy, right? So d phi 1 by dt plus again 1 by b2 is replaced by 1 by r2, d phi 1 by dt minus d phi 2 by dt. Okay, so again let's solve it now. I of t is equal to c1 into d by dt of d phi 1 by dt plus 1 by r1 into d phi 1 by dt plus 1 by r2 into d phi 1 by dt minus d phi 2 by dt, and also we know that v is equal to d phi by dt. Okay, so now let's replace d phi by dt by v, that is c1 into d phi 1 by dt, so v1 by dt plus 1 by r1 into v1 plus 1 by r2 into v1 minus v2. Now for this we need to apply the Laplace transform. So taking Laplace transform, so this I of t would be replaced by I of s is equal to c1 into d by dt is replaced by s, v1 is replaced by v1 of s plus 1 by r1 into v1 of s again plus 1 by r2 into v1 of s minus v2 of s. Okay, so this is for equation 1. So how many equations are over? 4, right? So name it as equation 5. So now let's consider for equation 2 again. So since we have no force here, so automatically the force is equal to 0. So again m2 is replaced by c2 d square phi 2 by dt plus b2 is replaced by 1 by r2, again d phi 2 by dt minus d phi 1 by dt plus k is replaced by 1 by l phi 2. Okay, so now let's solve. c2 into d by dt of d phi 2 by dt plus 1 by r2 into d phi 2 by dt minus d phi 1 by dt plus 1 by l into phi 2. So we know that v is equal to d phi by dt, so d phi 2 we have, so d v2 by dt plus 1 by r2 into v2 minus v1 plus 1 by l into, we know that phi is equal to integration of v, right? So we have integration, phi 2 would be integration of v2. Okay, so now again we need to apply Laplace transform. Taking Laplace transform, we get 0 is equal to c2 into d by dt is replaced by s and v2 is replaced by v2 of s plus 1 by r2 into v2 of s minus v1 of s plus 1 by l, and we have another integration, so it's equivalent to 1 by s into v2 of s. So this is one more equation, name it as equation 6. So now using equation 5 and equation 6 we would be building a circuit, okay, for a FI analogy electric network. So since we have two voltages here, we need to use the node voltage analysis. So write the two nodes and name it as V1 of t and V2 of t. Again we know that for node V1 we have the current I of s. So first in place of V1 node build this current source and name it as I of t, and after that under node V1 we have how many components here? C1 of s, C1, R1, as well as this R2 is between these two nodes, right? So if R2 is between these two nodes, what we need to do? We need to write this R2 between these two nodes, okay? Since we have R2 common to both V1 as well as V2, okay? Yeah. So along with the V1, what and all we have? C1 and R1, but those two should be in parallel. I've told you, right, in FI analogy the components must be in parallel to each other, and in FV analogy the components should be in series to each other irrespective of the node or the loops, okay? So we have C1 as well as R1. parallel, right? Yeah. So now let's go for node 2, that is V2. So what and all components we have? One is C2 and another one is L. Okay, and this R2 we have already written it, right? So yeah, C2 and L. So again those two are in parallel, C2 as well as L. So this is C2, L, C1, R1. Okay, so this is your required electric network. Okay, so again we have built two circuits for FV Anology and FI Anology. Okay, so hope you like this video. So please refer this video, and if you do not understand, please refer our previous video. We have delivered the basics for this concept as well. Since if you are new to this video and you are not understanding this problem, so please refer our previous videos. We have solved it. We have solved one problem and explained it briefly to you. So observe that problem as well, and after that observe these two problems as well, which we have solved in this video. So that's all for this video. Please like, share, subscribe, and please share this channel to a huge number, and also comment down your precious opinions. We are eager to listen your opinions about our content which we are delivering. So please comment down. Please like, share, subscribe. So we would be meeting in the next session. That's all. Thank you.